Hi, this is a video for PGCon Israel 2020. Unfortunately, due to COVID circumstances, we cannot meet in person, but you can watch this video and I will be happy to answer your questions. And today I'm going to talk about Odyssey. Odyssey is a connection pooler designed for high performance installations, Postgres installations. And my name is Andrey Borodin. I'm team lead of open source relational database management system development team at Yandex Cloud. And let's talk about connection pooling. Actually, connection pooler is a simple tool to relay bytes from one network socket to other network socket. This is quite similar to a full network multiplexer of connections. It just takes your query and goes with it to database. But let's start from some description of Postgres at Yandex. We have a Yandex Cloud with few petabytes of Postgres. It serves on average 3 million queries per second. And there are a lot of different services of Yandex in Postgres databases like Yandex Mail, Yandex Taxi, and some others. And so we encounter problem of installations at scale, and we visited DSA to solve our problem. And one of our problems was a number of backend connections, client connections to the databases, and why this problem needs to be solved. Because each client connection is one process of a database which have its own caches, and if you have thousands of different connections, these caches are duplicated and occupy a lot of memory, and they are not very efficiently used. But that's not the only reason. Actually, Postgres is transactional database, and there are a lot of transactional algorithms which are linear, which have a linear dependency from a number of currently connected clients. For example, taking a snapshot at the beginning of the transaction is algorithm which requires examining every single connected backend. And there are a lot of similar places. And so with a lot of connections, everything tends to be a little slower and slower and slower. And with thousands of client connections, you can have unexpected problems connected to number of connections. How to reduce number of client connections to the database? First and most widely used way is to use application-side pooling. If you have a driver which pulls connections, that probably its first step is to enable this application-side driver-side pooler. Second, you can have some middleware, some proxy, which accepts thousands of connections and tries to pack it in as small as possible number of connections into the database. And finally, at some point, we will have built-in connection pooler. Now you can see GSSAPI hackers made at least a lot of work on built-in connection pooler, but it's not quite there yet. Well, at the beginning, you have application-side connection pooler, which pulls big number of clients into a small number of server connections. And then you must have different backends for different microservices. And some services are load balanced between some instances, and each instance of a backend have its own pool. Then you need to deploy your application into many availability zones, into many data centers, and you have multiplication of previous connection pool into number of data centers. And at some point, you encounter limit of one instance database, and you need sharding. You need to go to different databases, and then instances start to tend to be messy because at each single step you multiplicate and multiplicate and multiplicate again number of TCP connections, number of client connections to the database, and you get to the problem of pooling. What are proxy poolers? What can we choose from? We can use PgBouncer. There is a Crunchy proxy, is somewhat similar project to PgBouncer, but written in Go, and relatively new project PGDay. They have a diverse functionality, but most of the time they provide session pooling. That means that each client have his own server connection. This is a good for developer. This paradigm allows to use temporary tables, allows to use advisory logs, and some other things which survive between transaction boundaries. But the ratio of reduction number of client connection to server connection is relatively small. You can defer opening server connection until the client connection first asks a query, but then you have to bind server connection to client connection. There is a PgBouncer, lightweight connection pooler, which allows transaction connection pooler. That means that server connection is bounded to client connection only during the transaction, and after the client finishes his transaction, rollbacks or commits, this server connection is returned back to pool and can be used by another client connection. So if the client connection is silent, is not creating any new queries currently, it doesn't occupy any resources from the database, which was the actual point of reducing number of connections to the database. So we like PgBouncer on our workload very much, to solve a lot of our problems. But yet it brings some other problems. For example, PgBouncer completely opaque with errors of connection. You just don't know why connection failed to the server. It just says that no, PgBouncer could not connect to server. Was it wrong password? Was it too many connections to the row, or some other problems? You just don't know. And then you can find that PgBouncer is a single thread application, and there is not so much of things they can do when you encounter this problem, because PgBouncer is about relaying bytes from a socket to socket. There is no any mathematical computation. There is no point to use CPU when you relay bytes. Yet it examines some internals of packets, and it is termination of SSL, termination of cryptography, which is CPU intensive from time to time, and you can get to the point where when one PgBouncer is a limit. But you can apply small patch to the PgBouncer. You can allow to reuse TCP socket, and you can spoon multiple PgBouncers. You can create a cascade of PgBouncers. Why would you need a cascade? Because you have a layer of PgBouncers, which is a termination of cryptography, which is doing SSL handshakes, which creates new cipher connections. And then you need to analyze packets yet, and you cannot do it with one internal PgBouncer. You still need many internal PgBouncers. So you have a cascade of say 16 external PgBouncers and say 2 or 4 internal PgBouncers. And external cascade may operate in session pooling, while internal cascade is actually doing pooling and is operating in transactional mode. Currently, this is a recommended way to install PgBouncers, and it's not easy to manage this cascade. But that's not the last problem of PgBouncer. For example, when for some reason you do not cancel your query, but just network is broken and you lose a connection to PgBouncer, it already is running some CPU consuming, resource consuming query on the server. PgBouncer will allow the query to finish, even if no one is waiting for its result. And when you are doing a lot of analytical queries, if the network is broken, or you use a client which is not used to sending cancellation of a query, you may end up draining all the resources of the server just because of some network glitch. So this problem was somewhat fixed by a community 3 or 4 years ago in pull request. This allowed to cancel queries which have no client waiting for its completion. Yet this pull request is not merged yet. The problem with PgBouncer is that it's not actively developed, and if you want some new feature, good luck with it. That's why we decided to create our own connection pooler, which is called Odyssey. Odyssey is based on 2 libraries provided along with Odyssey, which first one is Kiwi, and second one is Machinarium. Kiwi is our implementation of Postgres protocol. Kiwi is a number of C functions which allows you to format messages from Postgres protocol, protocol 3. It's quite straightforward, just names are usually self-describing. Machinarium is a little trickier. Machinarium is a trading library actually which operates with abstraction of workers and coroutines. Worker is effectively a thread or process in Unix way. Worker is a thread which working on advancing coroutines. Coroutine is resemblant to Go routine in Go or Go program. Simply, it's a green thread. It's a thread that is for example, coroutine have its own stack. And when it needs to wait, it swaps context and returns its context to worker. So one worker is a thread running many coroutines. When a coroutine is waiting for data or waiting for timeout, it calls sleep or epoll or some other function to wait for data, and just returns its own schedule CPU slice, not to the kernel, but to some other coroutine running on the same worker. This allows to pack thousands of coroutines, thousands of green threads into 4 or 8 CPU threads, actual system CPU threads. And then comes architecture. We have a worker for a main function, main worker serving 5 coroutines. System coroutine is doing simply accept of TCP connections, and after accept, client is bound to some worker which is responsible for running the TLS handshake, running cryptography, CPU consuming, and then doing all the regular bytes relay between client and server. We have a router coroutine which serves router purposes, and server coroutine which examines which servers are working right now. Console coroutine is resemblant to PgBouncer console database, which serving for system purposes for if DBA want to change some settings running Odyssey PgBouncer, and cron which is responsible for obsolescence of old server connections. And main worker is also responsible for holding pools for each combination of database and user. Problems which we encounter during our exploitation of Odyssey in production. First of all, for a long time we had memory leaks. We've been doing tedious work to track every single byte location, and until release 1.0 we had some memory leaks, and users were reporting it to us, and we were fixing this. This is a common problem for C programs, and yet it just requires tedious work to solve these problems. And second problem was that we can have TLS connection from client to Odyssey and from Odyssey to Postgres. Usually we run Odyssey along with the Postgres on the same machine, and there is no need to cipher to encrypt traffic between Odyssey and Postgres, but some users do use it. And you need certificates for both client and server connections. And these certificates needs to be reloaded. In the first version of Odyssey, we were loading certificates on each client connection. Client certificates on each client's connection, and it led to the unexpected problem that when you have a multi-threading scalable pooler, but you read from a not very scalable file system these certificates again and again and again, and even when they are in cache at big wave of incoming TCP connections, this can be a problem. And we did not observe this problem in time and tried to solve it in another place. So now we reload client certificates only on a SIG-hub command on service Odyssey reload, but it allowed us to make our accept channel better. How we did it better? We inverse priorities. This is quite common technique of accepting. For example, we have a wave of 1,000 of simultaneous incoming TCP connections. Each one will be SSL connection. We are not doing 1,000 of SSL handshakes simultaneously. Instead, we pick 16 most recently connected clients and handshake with them. When they are done, when one of them are done, we pick again one most recent connection and put it into a handshake pool. Why we are doing this way? Because when you have more load, which is more than you can handle, you need to handle at least partial, at least part of your incoming requests. And if you are starting first in first out handshakes, at some point you get to the situation when everyone gets the same timeout, when you can serve 0 queries. That's why we had to inverse priorities and start accepting with the most recent new connection first. Then we have some problem with the fact that SSL is not the only way to encrypt data in Postgres protocol right now. When we had a release, some new clients tried to connect using GSSAPI, and Odyssey was considering this as a violation of a protocol. Like, I don't know what bytes are you sending to me. Goodbye. Now it's fixed, but it was somewhat unexpected in production. We are allowing to pass replication protocol through the Odyssey, so you can run logical and physical replication. First, we had a configuration for this. So, as a database administrator, you had an obligation to say that yes, for this database, we allow to pass physical replication or logical replication, but at some point we understood that we don't need this configuration. When a client comes in and says, okay, this is my login, this is my password, I want physical replication, we will authenticate him using our credentials and then ask a database, is it okay for a database to open physical replication connection? If so, okay, we will grant it. And that's how replication with Odyssey works right now. And then we had a problem with managing number of server connections. We were encountering strange situations when server unexpectedly needs to allocate thousands of running server connections and then do not need it for some minutes. The problem is that starting next server connection is not immediate, it's very time consuming, and it may take up to 50 milliseconds to run new Postgres backend. And when you have, for example, when you need more server connections than currently is running, you are starting to create new server connection, and we understood that we need to limit this. And then it helps to tackle peaks of queries. And now we understand that actually predicting number of required server connection is actually a task for machine learning. Why it is? Because obviously you do not know load in the future. But when you have not enough server connections, you will have slow responses from database. Small in OLTP sense, like you will not answer in 1 millisecond, but will answer in 10 milliseconds. For some services that it may be crucial. Vice versa, when you have a lot of server connections, if you have thousands of server connections, things tend to be slow. So small number of server connections is bad, and big number of server connections is bad. And I think we need some machine learning to pick optimal number of server connections for given workload. But yet we didn't implement it. Currently, you have to tune number of connections which can be opened simultaneously, and maximum number of connections allow maximum number of active transactions running via route, and route is a user and the database. Now we have this client max routing, which is a setting to limit number of simultaneously opened client connections. And no, it's another slide. So client max routing is a number of concurrently routed clients, which is a part of a solution of priority inversion. And the other part of this problem is that some clients tend to be slow, and if they hang for an indefinite period of time, they occupy some of these 32 client connections and routing stops at all. To prevent this, we say that if a client is authenticating for more than 15 seconds, we simply disconnect with this client. How to set up and monitor Odyssey? Well, you need to specify which port you are using and which type of TLS you are using. You have to specify how to connect to a server, and remote connection means that you are connecting to Postgres. Local means you are connecting to administrative console. You have to specify database and users and provide their credentials, how they are authenticated and how they are then logged to the database. One of the features of Odyssey is that we provide not just average time of a transaction and average time of a statement. We compute quantiles for queries and transactions, and this allows you to observe that some small fraction of your workload is now very slow and problematic. And this is more accurate instrumentation than monitoring average transaction. You can monitor utilization with usually it's about CPU utilization. Situation is about are you actually using routing? Client connected over time to Odyssey, and we have a view for errors of routing. You can get number of errors from administrative console. We are working now on online restart feature, and it's slightly different from PgBouncer online restart. PgBouncer can handle socket descriptors from old instance to new running instance, but it doesn't work with TLS connection, and we usually use encrypted TLS connections. And how it will work in Odyssey? In Odyssey, when you are restarting, Odyssey will slowly disconnect all clients from old instance of Odyssey. Meanwhile, it opens on the same TCP same TCP port, allow new connections. So first it allows to new clients to connect newly started version, and then one by one removes client connections which are not running query right now. We are appreciating contribution. We will be happy to you pull requests or just requests for new features. For example, we had a contribution with Scrum authentication, with pause resume commands, and search pass as a startup parameter. And now I'll be happy to answer your questions. Also, there is a GitHub repository specifically for this talk. You can create issues there, and I will answer your questions in details. And this is it. Thank you very much for watching, and I hope we have some conversation right now. Thank you very much, and goodbye.